In the past couple of decades, mankind has discovered some really amazing catalysts that do extremely exquisitely selective and really efficient reactions. It turns out that we know very little about how these catalysts actually work. So our research group, we focus on studying these reactions using theoretical and computational tools. Essentially what we use is we use computers to figure out, using mathematical tools to figure out exactly what part of the catalyst does what. To put it really simply, there was a video game I used to play as a young kid, and it was called Master of Orion 2. And occasionally there were these random events that would happen. You control one of 8 galactic civilizations, you try to take over the galaxy. And there was this random event in which a civilization would discover this lost ship, this ancient, more technologically advanced ship. And your scientist, if he discovers this ship, would be able to decode some of the technology and make it their own. So it was a tremendous leap in technology that you could get through these random events. So it turns out today in the chemistry world, there are a lot of these catalysts that do really powerful reactions, but we know very little about how these things actually work. We know they work, but we know nothing about what part of the catalyst actually does the catalysis, what part of the catalyst actually does the selectivity, what part is responsible for the reactivity. This NSF Career Award allows us to do 2 things. One is tell a story about how these catalysts actually work in the flask. When you run the chemical reaction, this allows us to tell the story about how these catalysts actually look like before it runs the reaction, while it's doing the reaction, what it looks like, and after the reaction, what it looks like. We can tell what the major players are, what the key factors that control every aspect of the reaction. This NSF Career Grant is actually a story about this amazing group of students, of 9 students and a postdoc and myself, trying to build their careers and try to advance the science and technology and our fundamental understanding of our natural world through the NSF Career Grant. So at the final year of my graduate school, there was this one time in 5th floor Molecular Sciences, which is the science building at UCLA. It was about 6 p.m. and I was looking out into the horizon across the parking lot structure, and the sun was setting over the mountains in LA. And I was thinking about something very deeply, and my boss went by, and he comes to me and he says, "What are you thinking about, young man?" And I say to him, "Well, I don't think I'm cut out to be a faculty member. I think I should go look for a job as a high school teacher, things like that." And he looked at me and he said, "Nah," and he just walked by, and that's when it was decided that I'll become a faculty member. So in all seriousness, the reason why I decided to become a faculty member is because there's a scene in this TV show called The West Wing, which I really like. And there's a scene about yacht racing. And when you do a yacht racing, one of the worst things that could happen is have kelp stick to the side of the yacht. And the reason why that's bad is because what amateur sailors would try to do is stick their hand into the side of the yacht and try to pull out the kelp. And the reason why that's bad is because now your hand in the water creates more drag than the kelp itself, so the sailboat or the yacht becomes even slower than before. And life is pretty much like that, right? Nobody waits around for you to kind of sort out your issues and deal with problems that you have to get ahead in life. And I think graduate school is the perfect vehicle for you to find yourself, discover yourself, become who you are, remove all the kelp, and try to sort of get ahead in life. So in the sailboat analogy, the way it works is what you need to do is you need to take an oar and stick it into the water and do this pedaling motion so that the water can gently remove the kelp while propelling you forward. Graduate school should be exactly like that, and that's why I became a faculty member. So there's this person that I work with at the chemistry department. Her name's Luann Johnson. She works at the front desk. And I asked her one day, what makes you come into the job? I mean, it's really stressful, it's hectic, there's so many things to do. And she told me a response that I think in my deepest moments, I think that's absolutely true, which is you do it for the people. You do it for the students. For me, graduate school was a transcending experience. It was something that really changed who I was, matured me, and made me who I am. And I think it should be like that for all the students that are in my group that are in graduate school. That's what I really love about graduate school. When I see students that are that I mentor or that are in my class really come of age, become who they are, and really kind of, fully becomes like that age-old adverb, like, you know, you become who you want to become. You become aware. I think that's what I really love about this job. So how do I maintain work-life balance? I think it's very, very hard, at least for me, and you know, if somebody's figured it out, I wish they'd tell me. So I think in order to answer that question fully, I think the first thing that we need to talk about is, well, how much work is there? So roughly my day starts from 6 a.m. and then I work until 1 a.m. after my kids go to sleep. So in that time schedule, trying to find work-life balance is extremely hard for, I think, a typical person's job. I think the only reason why faculty members do it is because they absolutely love their job and the work and life isn't really separable. And I think to have family members and those around you that care about you, that kind of sort of understand that and be supportive is incredibly important. So work-life balance isn't a matter of time, isn't a matter of other things. I think it's a matter of commitment, and it's a matter of where you get your energy from. For me, I get the energy from the job, I get the energy from the family, and that's why I can maintain that kind of schedule. So I think I have two advice for the younger scientists. I think one of them is that it might not appear so, but people around you, the deans and the chair and your colleagues and everybody around you in the community actually really want you to succeed. There's nothing more important than having a faculty member succeed, because they actually teach the graduate students, they teach the undergraduates, and then that's what propels the entire educational enterprise and the humanity forward. So everybody that's invested in this entire enterprise really want you to succeed. And sometimes it's really hard to see that because you're so stressed and you're so worried about so many things, and you see a lot of kind of events that are sort of neutral, but you're haunted by your demons, so they turn out very kind of negative. But in fact, everybody's really genuinely supportive, so you just have to remember that. The second piece of advice, I think, is the hardest thing to do as a faculty member, as a young scientist, is to conquer your fears. I think it's so, we're so, in general, very skeptical of our abilities, and I think there's this feeling among young faculty members, that even senior faculty members, that they feel like a fraud, even though they've done all the amazing work. And I think a big part of that equation is you need to be able to conquer your fears, and you need to be able to deal with that. And whatever you do, I think if you can do things and motivate yourself to do things without having that fear kind of haunting you, I think you'll be a true success. I guess in the official statement, it's that Professor Cheong won the Career Award, but I don't feel that way. I think that, you know, my students and we sat down together in a room and we labored for weeks and months to write the career grant and to think about the science and where we want to go and the type of scientific issues that we want to deal with. So for me, it's actually a question of how does the group feel? How do we feel inside the group that now that we've got the Career Award? And for me, that's, what can I say? It's like, it's wonderful. We're really humbled by the award, but we're also extremely energized because this, you know, we see that this is actually working. That us together in a, 4 graduate students or 5 graduates at a time, 1 postdoc and me stuck in a room for 3 weeks, and then we labor on science for 4 or 5 years, and we get the career, and that's an incredibly humbling experience. But it also, I think, it tells the junior students that, yeah, they were part of the successful enterprise, and in their own independent career, they'll be able to replicate that kind of success, and I think that's more important than anything else. So I feel extremely humble, and we feel ecstatic.